normal queues, we are saying that here, this is the queue, we delete elements here at the front and we insert elements at the end, that is at the rear end, at the front end. Double-ended queues means in a queue, you can perform both insertion deletion at both the ends. Okay, short form is DQ, DEQUE, that's it. But we have another word, that is DQ. DQ total means it is deleting an element. Double-ended queue is written as DEQUE. Okay, so double-ended queues meaning in normal queue you can do deletion at one end and insertion at one end. Whereas in double-ended queues you can perform both insertion deletion at both the ends. That is double-ended queue. Okay, you will have with the one pointer only you can do both insertion and deletion. So see here, double-ended queues are called DQs for short. Okay, DQs like this, right? It is exactly like a queue except that it does not follow FIFO rule. It does not follow first in first out rule, right? Elements can be added or removed either at the front or at the back of the queue. It can be inserting and deletion can happen both ends like this. You can insert and delete at both ends, right? In this, there are two different types of DQs. There are two different types of DQs. Okay, what are the input restricted queue, output restricted queue? What are these input and output queues? Let's try to understand. Input restricted queue means, see, this is in double-ended queue. I am saying that I can perform insertion at front and I can perform insertion at front, deletion at front. Even I can do insertion at end, deletion at end. This is normal double-ended queue. Input restricted means insertion can be done only at one end, while deletions can be done both ends. Okay, insertion is not allowed here. At front I can insert and delete, at the end only I can delete. That is input restricted queue. You cannot insert element from one end. Okay, this is input restricted queue. Whereas the next one, output restricted queue, means you can, what is our general principle? General principle of queue: insertion here, deletion here. So in input restricted, this insertion you cannot do. In output restriction, generally where we do output, where we DQ the element, we DQ elements from here. This is restricted. I cannot delete elements from the beginning. I can do it from the end only. But input I can do both the ends. I can insert the elements at both the ends, right? In the output restricted double-ended queue, deletions can be done only at one of the end, while insertions can be done on both ends. Okay, so there are two different types of queue. One is input restricted queue, other is output restricted queue. Otherwise, the base normal DQ is you can perform insertion, deletion both at both the ends. Okay, so how we implement this? Now see, how can we implement this double-ended queue? Okay, I'll come to this circular array logic later. Let's see this double linked list logic. See, it is same as your double linked list. No, in double linked list we are saying that, in double linked list we are saying that you can insert elements at any end. You can insert or delete the elements at any ends. That's what we have studied in linked list concept. Implementation of DQ using double linked list is very easy because inserting an element from the beginning, deleting an element from the beginning is possible. Inserting element from the end and deleting element from the end is also possible, right? So what logic you have tried? If you want to implement double-ended queue using double linked list, we cannot use single linked list here because I want to come back also and go forward also, right? So we have to use double linked list. In double linked list, we have seen already that it is very simple. Inserting means inserting at the beginning of the node, deleting at the beginning of the node. Same way, inserting at the end of the node, deleting at the end of the node, end of the list. These four operations, if you implement, you can easily achieve the double-ended queue logic using double linked list. Okay. What about circular array? What about circular array? How can we do this circular array implementation of double-ended queue? Right? Here you have to, in circular array, you have to write 4 functions. If circular array is like this, if this is the case, some small size I am taking. Assume this is my front and this is my rear. Okay, right? Now I can insert element here also at the rear end, and I can delete here also. So if you are inserting, so that's what you have to write. You have to write 4 functions. That is, in generally we call NQ, right? So NQ begin is one function, NQ end is one function. Same way, I am writing shortcut again. DQ begin, DQ end. 4 functions you have to write here. Now, generally what we are doing in a normal queue, what we are doing, if you want to insert element, increment the rear value and place it there, one time activity. If you want to delete the element, move your front pointer and remove that element. This is what you are doing. NQ begin means I want to insert at the beginning, means I have to insert at the front here. I have to insert at F. So in NQ begin logic, what I have to do, I have to increment by my F. I have to move my front forward. I will not say +1. I have to move my front forward. NQ at end. NQ at end means I have to insert at the rear end. So I have to move my rear forward. Same way, DQ begin means delete. This is normal. You have to move, reduce your front, and DQ end means you have to move your rear, reduce it, right? So in circular queue, normal queue and this double-ended queue remaining, everything is same. Only thing, you have to write 4 functions here. Insert NQ at the beginning, NQ at the end, DQ at the beginning, DQ at the end. Okay, so it's again small modification. You know how to write it. R equal to R plus 1 modulo capacity. So this will move forward the rear end. That means you are inserting at the end. That is normally there. How do I insert at the beginning? In insert at the beginning, my F is here. My F is, that front end is here. This I have to move it forward and insert the element here in cycle. Okay, so just that logic you have to write. You have to move forward your, you have to move. If your front is here, I have to insert it here. So I have to do F minus 1 modulo capacity, here F. Same way, R minus 1 modulo capacity and F plus 1 modulo capacity. This 4 just small logic we can write in double-ended queue, right? So double-ended queue means you can insert and delete the elements at both the ends. Easiest way is to use linked list. Using array also it is possible. You have to write 4 functions here. In double linked list also we have to write 4 functions. But again, this is known to us, nothing new. Just change the name of the function, make it NQ, DQ, job is done, right? So this is about the double-ended queue or in queues.